We're on. All right, so here we're translating these motion diagrams, these quantitative motion diagrams. We've added numbers into our number line, so now we can actually do something with it. All right, so we want to take this and put it onto a graph, a position versus time graph to be exact. So we have our X and we have our Y. All right, so remember that these motion diagrams are created like with a strobe light flashing every second. It's showing how far it has moved each second. So at t equals 0, what is our position? Oh, just look at the number line, it's 5. Oh, okay. T equals 1, what's our position? We went 1, 2 tick marks. It looks like between 5 and 10 there's 5, so then we are now at position 7. It's not our displacement. It's not our change in position, it is our actual position at that exact time. This is not a time interval, it's clock time. Alright, so at t equals 2, we're at 9, and then 3 is 11, and then 4 is 13, and then 5 is 15. This might get a little messy here with a big pen. Alright, we'll do what we can do. At t equals 0, we are at 5. Let's make that a little bit bigger. At t equals 1, we're at 7. So 5, 6, 7. At t equals 2, we are at 9. I think I can do a better 9 there. Yeah. Excuse my not being straight. T equals 2, 3 is 11. There we go. 4 is 15. And 5 is about 15. Alright, let's see. We've got now we would take our ruler and we would try to get our line of best fit. Luckily this is all like not actual data, so our line of best fit is going to be pretty perfect. But remember, normally you want to have as many lines above as you have below. And you want to get as many points on here as possible. Goodbye, ruler. Excuse me. There we go. Come on back. There we go. All right. Well, there we go. We got number 1 done. Good for us. Continue on. I'm going to actually fill in. Oh, we're not done with number 1. We're not done. I wanted to do something here. So the equation for this line we know is going to be y equals mx plus b. So let's break this down. What is our y-axis? Well, the y-axis is position. Our slope. What's the slope of position versus time graph? You have to memorize it. Is our velocity. X is going to be our time. And then our y-intercept is our initial x, or that little knot there. X knot. So our equation for this graph is going to be, we can see our slope. We went up 2 and went over 1. So we have created a function here, and we know that this is 2t plus 5. So now we can take this graph and we can plug in any old time that we want, and we are going to get our position. So that's the idea of a function, right? You have an input and an output. The input is going to be any t value. If we plug in 0 here, then 0 times 2 is 0, plus 5, x equals 5. Is that true? That's true. If we plug in 10 here, 10 times 2 is going to be 20, plus 5. I think we can safely say that at t equals 10, we will be, as long as everything stays the same, we will be at position 25 meters. That's extrapolation. So there you go. We have created our own function. We have written an equation. Good job. Pause this here. So to do the next one, you're going to use the same markings as the first one. 0, this would be 5 meters, this is 10 meters, this is 15, and 20. So it's going to be the same for all of them. Down here and everything. There we go. Okay. Alright, so I gave you that one there. And then down here, hopefully you'll notice that we're moving down. So we're going to be moving to the left. We're moving closer to 0. We're going in this direction along the number line. Very funny. There we go. Alright, so as best I can, I will try to do that, but it's super tough for me to do this, and I am so sorry. I was messing with it while I had the video paused. So if we're starting at 20, and then every 2, we're going to the left, right? Because we're going down 2 and over 1, so then our slope is going to be a -2. Our rise over run is -2 over 1. Our rise is -2, and our time interval along the bottom is 1. So you would make your, let's pretend like there's arrows on here and they're all the same length because this is a straight line. Our velocity is not changing even though we're moving to the left. Left is just a direction because remember, velocity is a vector. So your equation for this line would become x equals -2t plus 20. And then over here, I'm just going to give you x equals 4t plus 0 because we're going through this, because we're going through the origin. So this is an exciting example. This means the relationship between position and time is directly proportional. Now this is very different from the first graph in that our x naught, or at t equals 0, this b term here, is not 0. Because it's not 0, we could only say the relationship between position and time is linear. It's not proportional. Linear. Line E R. Linear. I hope you're not too messed up. Please ask your neighbor, ask me questions to clear any of that up if I wasn't perfectly